Good afternoon, everyone. This is Ryan Miller with North Carolina Building Performance Association. We are very happy to have you all on today's webinar. We are doing an expert virtual panel on Passive House in North Carolina. Despite the name, folks probably know at this point, residential and commercial buildings. So we are happy to have you all on. NCBPA does webinars and events and meetings and phone calls and all kinds of different industry activities to promote opportunities, technologies, market solutions, things like Passive House. So we're happy to be doing this one today. So today's webinar will be about an hour and a half in total or so. So please get something to drink and be ready to take some notes. As I mentioned in the warm-up here, we will be recording today's webinar, so everyone will receive a video link to the webinar as well as a PDF, and you're welcome to share that with your coworkers and with your partners as well. Sometimes in NCBPA we do webinars and events for members only. Sometimes we charge a fee. This one was free. It is part of our monthly Passive House committee that we run. So we'll be talking about that a little bit more later. But if you are interested in this topic, NCBPA is doing quite a bit of work on Passive House, and we'd be happy to work with you. So just a little bit of information to get started, and then we are going to jump right into the presentation today and our expert panel. So first off, we will do a little bit of information here on NCBPA. So North Carolina Building Performance Association, we were formed back in February of 2014, so a little over 5 years old. Over on the left-hand side, there's 3 different reports from about 2016, 17, and 18, talking about some of the different energy efficiency, building performance, and green building policy and market work that we're doing. Top right, you can see a couple of photos on workforce development and some presentations that we're doing. There's a crawl space workshop coming up, July 9 and 10 if you're interested in Charlotte. And then also policy work. I spent my morning today at the legislature, and we are very actively trying to push North Carolina General Assembly and other stakeholders to support good, energy efficient, green, high performance construction policies in the state. So that's just a little bit of a snapshot of some of our work. Workforce development policy are very important to us. We also do code work. Also doing a lot this year to engage with our industry members and leaders to put them in positions to be successful and have some visibility in the marketplace. So a little bit about NCBPA and what we do. We are a member-based association, so we are a not-for-profit. If you are interested in joining NCBPA, we would love to have you join as a member company. Membership is open to all industry companies, and then anybody working at those companies can have access to that membership. Membership dues start at $25 per month per company, so that's $300 per year. There's a mid-level for $450 and then a higher level for $600 for large companies. We do have a bi-weekly newsletter, so we send out probably way too much information about what's going on in the market because there is quite a lot at the local, state, regional, and at the national level. So if you are interested in staying up to date on not only Passive House, but building code, policy, workforce development, and other market initiatives, please consider joining NCBPA. We do have discounts to industry events, conferences, and some vendors as well. You can find all that on the member portal on our website. It's members only, of course. We do offer opportunities to participate in a couple different committees, member meetings, and then also our board of directors as well. So we do have a Passive House committee. It's one of 3 active committees that we have right now. We've done some others in the past. You can find that information on our website as well at buildingnc.org. And then throughout the year, of course, we do different types of member meetings, and our board of directors is our volunteer-led leadership group. So you are welcome to join NCBPA at your convenience. It just takes 5 minutes online, just a simple form with some contact information, and we'll get you into the association. It's a year, 365-day membership, and as I said, open to all industry companies and all professionals. We definitely appreciate your support. So just a little bit of a preview. We are getting close to hopefully making an official announcement about this in the near future, but we are planning at the moment a 2020 Southeast Regional Conference that would be held in Raleigh in mid-August of 2020. We've taken a couple of years off from doing our conference because there are lots of conferences out there for us all to go to. But we are interested in doing a co-located conference with some partners that may include USGBC, ASHRAE, Air Barrier Association, and some other organizations that have expressed interest. And so if you are maybe in a volunteer board committee position at an industry organization of those types, or if you're just interested in becoming potentially a sponsor or an exhibitor or a presenter for a pretty big 2 to 3 day conference, we're hoping to pull in around 750 people. We are working on that one. We'd be glad to happy to talk to you about that in a little bit more detail. So also, some of the work that we do at NCBPA is to promote opportunities like this one with Passivhaus. And this is one of my favorite quotes. We have about a 26 or so minute video on our website under the members section if you want to see this. This is, I believe, going to be the most airtight residential home in the Southeast. I think it's just been completed. We're getting very, very close to it. It is being built to the Passivhaus standards, and Dylan, who is one of the 2 builders for this project, along with Will Alphen, provided this quote, totally unrehearsed, and I love it. He said, "We're never going to get to our carbon targets or energy targets just by ramping up our solar production. We need to be efficient, reduce first. A dollar towards efficiency goes a lot farther than a dollar towards production. That's what we do." So very happy to hear that information from one of our members. And again, there's more information on our website with that. So, so I do want to thank everybody for joining us on today's webinar. We will have 4 presentations. They'll be about 10 to 15 minutes each, and then we'll be taking questions at the end of each one. As a reminder, please do put your questions into the chat box in GoToMeeting. We're going to keep everybody on mute just for the sake of background noise and things like that as we have more people signing in. So if you do have questions, put them in the chat box. We'll be monitoring that, and then we will check that at the end of each presentation as we go along. And then lastly, just one more mention, we will send out a PDF and a video recording of this webinar, most likely tomorrow morning, so be on the lookout for that. Final mention is just a quick thank you to our participants, our panelists today, Steve, Kristina, KG, and Leah. They and others have been participating in our monthly Passivhaus committee meetings that we do. We've been doing this for probably about 1.5 years or so at this point, and every month we get a couple more people to participate and talk about a couple more fun things. They take place on the 2nd Tuesday of every month at 2 p.m. It's usually just an hour-long phone call. It is for members only, but we do invite guests to participate and kind of learn about what we're doing, and then hopefully encourage you to join the association. But again, that's up on our website under the directories. There's a committee for Passivhaus, and then there's also an events calendar, and you can find that information there. So without further ado, I'll do a very quick introduction of each one of our panelists, and then we're going to kick it over to Steve, who is an NCBPA board member, to start the presentation. So we will have Steve Schreiner. He is with Schreiner Design out of the Lake Norman, Charlotte area, certified Passivhaus expert extraordinaire, and he will be talking about residential single-family projects, and so he'll be kind of getting us started with some background on Passivhaus for folks that are a little unfamiliar. Next up will be Kristina. She is an architect over at OnSite Architects in Charlotte, and she works on lots of different types of buildings, and so generally speaking, we'll call that commercial today, and she'll have a case study that she'll be presenting. Also on deck is KG, as his friends call him, with BuildSmart out of Lawrence, Kansas. He's got quite a bit of work here in North Carolina, and they are a product manufacturer with panelized wall systems, and he will be focusing on multifamily projects today. So thank you, KG, for joining us. And last but not least, I have a typo. I'm so sorry, Leah. I will fix that right now. Of Leah Dickens with Deltec Homes. Deltec is based in Asheville, North Carolina. Traditionally, they build those really cool, hyper energy efficient roundhouses that folks are familiar with, but Leah will be talking about some of their newer work with zero energy ready homes, and specifically how you can go from Passivhaus, mostly on the residential side, but some of that will apply to commercial and multifamily as well. How do you go from Passivhaus to zero energy ready, net zero energy, whatever you'd like to call it? So thank you, Leah, for participating as well. All right, and then lastly, that's a screenshot of the chat box, so please go ahead and use that as you have questions throughout the presentation, and we'll be answering those as we go along. So without further ado, I am going to turn it over to Steve Schreiner to kick us off. And Steve, if you don't mind, a little bit of the background on yourself, and you should have control over the presentation and can have at it when you're ready.
Thanks, Ryan. I'm a builder developer here in Charlotte, North Carolina. Have been building high performance homes for quite a while. Now I've gone more into the consulting business and helping people basically design and build, if you will.
Hey, Steve, are you still there? Hey, Steve, can you let me know if you can hear me? Okay, folks, I think we're having a little bit of technical difficulty with Steve here, so I'm going to take a quick pause and try to get that figured out. Steve, if you can hear me, we are unable to hear you at the moment, so we will hopefully come back to Steve. So we'll maybe take a little quick detour here and see if we can get Steve back here in just a minute. Steve, if you can hear me, we will.
Ryan, I hear you now.
There you go. Okay. Hi, Steve.
Sorry, I don't know what happened. Just all of a sudden went dead on me. So
gotcha. Okay. Well, go ahead, Steve. I can hear you just fine.
The slides don't seem to be advancing.
All right. I think I've got it right there. There you go.
Okay. Thank you. Okay. Sorry about that. The Home Innovation Research Center recently did a study that showed that builders basically are having a hard time figuring out how to jump into high performance building. Do they look at the building envelopes? Do they look at insulation, air tightness, the mechanical systems? And if they do a lot of this extra effort and expense, will their buyers realize what they put into it to see and pay for that extra? And there's a report that I'll refer to at the end of my presentation that will show that they will do that. Yeah. There's a delay. It's my fault, Ryan. Passive house program is made up of 5 principles. The first and probably most important is air tightness. The building envelope needs to be extremely tight. I'll show you those numbers in a minute. And the reason for that is the air tightness provides the full capability of the continuous thermal insulation, which is the second principle. And I do mean continuous all the way around the building envelope, including the bottom, which I'll go over that a little bit. The third principle being high performance windows. If the building envelope is doing its job, it's only fair that the windows should contribute to that as well. And I'll share with you a new window prototype that's being developed as I speak. The fourth principle is thermal bridging. That's a term basically for a material in the building envelope that may be allowing a short circuit, if you will, of energy to bypass the thermal capabilities or characteristics of the building envelope itself. And I'll show you some examples of that. And the fifth principle, as we tighten up the envelope, we have to turn our focus to making sure that we have a clean air supply, air circulation in the building envelope itself. So I'll go over that, briefly go over that as well. Starting with the building envelope, I like to compare it to basically the leaky bucket syndrome, where think of you're trying to fill a bucket full of holes and you just continually have to keep the water flowing to basically equate to the water that's escaping. And that's about the same scenario if you think about it with a leaking building envelope. What would normally happen in a conventional construction, you have infiltration, exfiltration, and that air needs to be continually reconditioned, which takes energy to do that. And that's the wasteful energy loop I show in that cartoon. I borrowed these slides off of Megan McDermott with High Performance Building Solutions, and she shows here in a chart 4 building programs starting with 2018 International Energy Conservation Code. They have a 5 air change per hour at 50 pascals air tightness requirement. You see LEED for homes, the NHB's National Green Building Standard, and then at the bottom, PHIUS, or Passive House Institute US, and they have a 0.75 air changes per hour, and that is a 0 before the decimal point. And so that's showing a 15%, only a 15% leakage rate compared to the IECC. This is a printout that I did of an optimization software that I use called BOPT, National Renewable Energy Labs. And it's a software that allows you to compare different building assemblies and the components and different combinations of them to find the most energy resourceful or energy savings, which would be the x-axis in this graph, as compared to energy costs, which would be the y-axis. So what I'm showing here is an optimization curve, and anything on those curves are the most optimized or cost-efficient and high-performing combinations of building components. The red I'm showing you, as you tighten up a building envelope, it gets much more energy efficient. And basically what I'm showing there is for every 2 air changes per hour that you tighten up, you're going to see somewhere between an 8 and a 10% increase in energy savings. Of course, there's all kinds of ways of addressing air tightness in the building envelope, your house wrap and taping that, of course, your window installation, and how you install that in the rough openings and how well you seal that, raised heel trusses to allow you better sealing and insulation possibilities at the upper wall and roof juncture, and of course sealing and insulating the rim joists, as well as using different materials and methods of air sealing. There are pre-manufactured sheathing systems that have air and water resistant barrier already applied, coatings applied to the outside of the sheathing, and in some cases there are some insulating characteristics of that sheathing, in other words, providing you an R sheathing, if you will. There are fluid applied applications as well. Usually that's probably more towards a multifamily or commercial type setting, and as well as there's an airborne chemical that is basically sprayed under pressure inside the building envelope, looking for cracks and crevices that air is trying to escape from the inside to the out. Okay, I don't want to blow you away with this table, but what I've done here is used an energy software called Woofy that was developed specifically for the Passive House program. And what I'm doing here is using the top line, the annual heating demand, as a performance gauge, if you will. And so what you're looking at is a number of different assemblies with different components in them, combinations of components, and how they perform. What I want to show you here is the red circle in the middle with a 3. That's 3 air changes per hour, and immediately to the right is 2 air changes per hour scenario. The only thing I've changed in these 2 different scenarios is the amount of exterior continuous insulation. I've cut it in half on the 2 air change per hour method. But if you note up above, the annual heating demand doesn't change a real great amount at all. It's very close. So what I'm trying to show you here is that you can have a trade-off between extra insulation and extra air tightness. So this provides those builders out there that may have a system that applies more to, say, they can tighten up their house easier than they want to go through the expense of putting extra insulation on. This shows you some of the things that you can do in getting combinations of things that work with your systems using a software like Woofy to help you out. Thermal bridging. Basically in this scenario, I'm looking at the lower left thermograph is showing the wood studs as the thermal bridge in the exterior wall. Wood is not as insulating as fiberglass insulation in the cavities. Conventional construction, 16 on center, you're going to see 23% or thereabouts of wood in your wall. Dance framing at 24 on center, you're going to lower that to 16%. The chart in the middle is showing the R values. The 21 is, of course, the cavity insulation, probably for fiberglass in a 2x6 wall. The 6.88 is the R value of the 2x6 wood stud. If you look below that, you're going to see a whole wall R rating that basically is like a weighted average, if you will, of the entire assembly. It's really an 18.5 or a 12% decrease because of the thermal bridging by the wood studs. The right lower corner shows that same table, but if I add about a ½ inch of EPS to the outside of continuous exterior insulation, I'm able to break that thermal bridge provided by the wood studs, and it gets me back up to a full wall rating of 21. So again, it's a little bit of a trade-off back and forth of how you can handle thermal bridging. Another method of handling thermal bridging of the studs, this is a product I just ran across. It's kind of interesting. If you look at the left upper photo, you're going to see two 2x3s that are connected by a dowel system in the middle, and it kind of looks like a bar joist. And what they do is they fill that void, and it's a 5½ inch deep assembly that will equal a 2x6 stud, and they fill that interior with closed cell foam insulation, and it gets the entire T-stud up to an R20 rating, which, if you remember the previous slide, we were at R21 fiberglass cavity. This is going to get the stud to equal the cavity. Well, this may be another way to break that thermal bridging situation without having to do the exterior continuous insulation. So again, this is to some of the flexibility the Passivhaus program has. Okay, this table I wanted to point out, again, another example of thermal bridging, and this is one that really even surprised me. If you, again, as I mentioned early, the thermal envelope also includes a bottom. In this case, it's the slab. And the circle in the middle is, those two assemblies are exactly the same except for one very important fact, and that is one has 2 inches of foam under the slab, the other does not. If you look at the annual heating demand above, you're going to see a 23-point difference. That is huge. So that kind of, even here in Charlotte, in a relatively mild climate, the slab to earth connection still provides a pretty good thermal bridge that you might want to consider. As I had mentioned about windows earlier having to do their fair share, I borrowed this slide off of Alan Ockoff with Anderson Windows. The Lawrence Berkeley National Labs, together with Anderson Windows and Alpine High Performance Systems, is doing research to develop a triple pane window that will have the characteristics of a double pane window with regards to width and weight. The trouble with triple pane windows normally is they're usually wider frames and they are much heavier, which makes it a little more challenged to incorporate in conventional building systems. So what they're doing is using a flat screen TV glass, which is extremely thin and thereby being very light as well. They're going to come up with a triple pane window that will be basically the same width of a double pane and weigh just about the same as well. This is in research, and they're hoping to have it to production in the next 2 years. And this would be an extremely important game changer for Passivhaus. Okay, let's turn to the inside and the mechanicals. This cartoon cracks me up. It's probably the best description of Passivhaus that I know. The far left, a couple hundred years ago, we started building structures for ourselves for comfort and safety, and we added fireboxes inside for a little bit of additional comfort. The middle sketch shows we thought we'd get smart in the 20th century and start adding a bunch of mechanicals, but maybe improving the outer structure, okay, but maybe not as much as we should. But all those mechanicals take energy to run them. The one on the far right is basically what Passivhaus does. We look at the structure and the envelope first and foremost to get it to the optimum performance, if you will, and then we supplement it with minute amount of mechanicals inside, and thereby decreasing greatly the amount of energy to run it all. Of course, as you tighten things up, you have to be very careful with the HVAC design, and that's when we have to implement the ACA, Manual J, S&D, to make sure everything is sized properly and will perform. What we have to be very careful with these airtight buildings is not only the sensible loads, but even more so the latent loads that normal construction doesn't have to worry about. But that's something that we take a good hard look at in Passivhaus design. Borrowed a series of slides off of Rob Howard over at Mitsubishi. This is to show you a myriad of products they have that will address the tight building envelope environment that a Passivhaus will cause. These are showing air source heat pumps, both ducted and ductless mini splits. I will tell you that as we get tighter, using combustibles, both for instance, heating, gas heating furnaces and gas water heaters, probably not a really good idea because of backdrafting. So these materials shown in this slide for heat pumps, electric heat pump related stuff is probably the way to go. As I mentioned earlier too, ventilation becomes very important. We do not have the easy airflow of a drafty conventional construction. We have controlled import and export air. We want to make sure that the new fresh air we're bringing in is pre-treated with the energy of the already conditioned air being exhausted. It is a dedicated system that supplies air to the bedrooms and living areas and exhausts air from the wet areas and odor areas such as kitchens and bathrooms. And I'm showing in the photograph here a couple of ERVs or energy recovery ventilators that are used for that process. What I like about the FIAS Passive House program is that it is not a one-size-fit-all program. It is very site-specific and climate-specific. Each of the balloons shown on that map of North America shows the locations that FIAS has analyzed using WFI and BOPT to get an output of targets that are also optimized for the location and the climate at that location. The chart in the lower portion of that slide shows the climate data that would be inputted into the WFI energy model together with your building assemblies to give you a very effective output for your different heating and cooling demands. As any process is the right time to do things, I would advise that the analysis part be taken into account during conceptual design before you get to construction documents. The different scenarios that I presented to you earlier in the presentation, what you would do in this case is you would enter those different assemblies and components into the WFI and BOP softwares to help you make decisions on what best works for your building systems or your particular design and the targets that you're trying to satisfy. One last chart. This is showing 4 building programs and how they perform with each other depending on each of the scenarios of building components that they're specifying, all the way from IECC, Green Building Standard LEED, FIAS. What I've done is on the far right come up with a design hybrid that I use as a kind of a test case. It's a 2 air changes per hour, 2x6 studs, nominal 25 R25 wall assembly, R27 wall assembly. And it does have foam under the slab for about R25 and an R38 ceiling. And you can see that it will produce a heating demand that's 34% of what the IECC components would. So again, this is an example of what the Passive House program can do to make a building really sing. And you can see the FIAS column in the middle there. They're 13% points below me even. To me, Passive House program is really a balancing act, if you will. It's the decision between short-term purchase and long-term ownership. How much do you invest upfront in additional construction costs to realize in the future savings through reduced utility costs? The quote up in the upper right corner pretty much sums up Passive House program. Again, it's all about envelope efficiency leading to energy performance. And the Passive House program is the ultimate program to follow to basically come to those conclusions. The 2 houses shown on this slide, the upper left is in Indiana. The lower right is in Canada, to give you an example of the styles and the different locations that Passive House does work. Recently, there have been articles about this program in Builder Magazine, which is the NAHB's publication. You might want to check that out. I think it was the January issue that they had the article in. And this is a report that our North Carolina Building Performance Association produced that shows that in the 3 larger metropolitan areas of North Carolina, buyers are really willing to spend 9.5% more to get this type of high performance home. And I'm sure Ryan can point you in the direction of where to get a copy of this report or to read it. And I can't resist It's a German building standard. So, wir sagen auf Deutsch, as we say in German, Prost, cheers. And since I've made myself pretty thirsty now, I'm going to turn it back over to Ryan.
That sounds great. Thank you, Steve. I'm always happy to see that slide of yours. So yeah, let's give your voice a break here for just a second. And I think something that we can do is go ahead and check the chat box to see if there's any questions. So as I'm doing that, I want to point out Steve is a board member, probably knowingly referenced a couple of our sponsors, Mitsubishi Electric, of course, so mini splits for residential and commercial, and also Ultra Air with their dehumidifiers. So we do work with those folks. They are sponsors of NCBPA. We appreciate everything that they do. So I am checking the chat box right now. I don't see any questions in there at the moment, which is great, Steve. That means that you said all of the right things and threw lots and lots of data on the screen that I think folks are going to want to look into later. So we'll give it just another minute or two here to see if anybody does have any questions. Steve, as we're waiting, before we move on, do you have any other just kind of comments or suggestions for folks on the residential side of Passive House?
First off, I apologize for sounding like a typewriter, but I wanted to try to get through all that information in the time allotment. But no, not really. I would go to the FIAS website. It's fias.org, and they do have quite a myriad of information on their website to help you get more familiar with what the program's all about, tutorials, reports, and whatnot. FIAS is the North American, or specifically the U.S. representative of Passive House, compared to the Passive House Institute over in Darmstadt, Deutschland, that started the whole thing. But again, as I said, the most important fact is FIAS has taken it to be site and climate specific, which is huge for us here in North America.
Very good. Thank you, Steve. And yes, we're definitely at NCBPA and Steve with our committee reaching out to FIAS, National Passive House Network, Passive House Accelerator, and PHI, Passive House International, to see if we can get some work going with them and collaboration opportunities. So if you know those folks, let them know. We are trying to push this program in North Carolina, can use their help. Steve, it looks like we've got one question here from Levi, so I'll throw this one out to you. Levi asks, how would you address future owners adding combustion appliances and creating possible backdraft or carbon monoxide exposure?
I guess I would strongly urge you to talk them out of that, or boy, you'd better be getting one heck of a strong disclosure or disclaimer, if you will. It's a bad idea. Depending on how, and I really should have prefaced that by depending on how tight the house is going to be, but pretty much any high performance tight house, you really, I'm not a pushing electric by any means. It's just a fact. It's a concern, and if you're concerned about it, you probably shouldn't do it. But as we tighten these things up, we really need to be careful with backdraft, especially if you believe this, people are even proposing fireplaces, and that is an absolute no-brainer no, unless you can get a completely air-sealed, direct-vented unit. But again, it's a risk. Do you really want to put yourself in harm's way if you don't need to? I would recommend strongly you try to talk your clients out of that. Oh, no, the other reason being that the energy savings, the performance level now of the heat pumps are much better than they were 30 years ago. The energy performance is so much greater that's another good way to try to convince them to go that route and avoid the backdrafting worry.
Okay, well, thank you, Steve, for all that building science, building data knowledge. We appreciate your update there on the residential side of Passive House, so thank you. I think we'll go ahead and move on, and we'll have time for questions here at the end as well, and then make sure that we provide Steve's contact information in case you would like to have some help from him as a consultant on your Passive House project. I'm sure he'd be happy to help. So moving on, we are going to transition over to larger building types. And so to do that, we have Kristina Held. She's with OnSite Architects. and she will be walking us through Passivhaus principles for commercial projects. So Kristina, you should have control, and if you don't mind, a short introduction about yourself, and take it from here.
Hello, can you hear me well?
Yes, just fine.
Okay, my name is Kristina Held and I'm with OnSite Architects, and I actually been trained as an architect in Germany and in Serbia, so that's where my interest comes from for Passivhaus here in the United States, because it's basically what we learned in school there. So I'm pretty familiar in it, and I was really excited when the FIUS came to the US. And I think it's even better than the one that they have in Germany because it's climate specific, and the US stretches across so many climates, and you can really create buildings that answer to any climate. So I'm also LEED certified, and that's how I started here, but I really didn't like the amount of administration that's connected with this, and I found that Passivhaus is much more user-friendly and also architect friendly, and it focuses much more on the envelope, and that's really where we as architects can make an impact. So I'll try to switch here. Here are again the 5 Passivhaus principles: thermal insulation, high performance windows and doors, air tightness, thermally sound details, continuous ventilation and comfort. And with this presentation, I'll be focusing on the first 4. So I'll be basically walking you through an existing design and how that thermal envelope was solved. Okay, and the importance of the building envelope being more robust than it is in other buildings is because you have accomplished a quality in the building that will never go away. So you can exchange mechanical systems, and maybe the solar powers will also not be as efficient after a time. But when we design the building envelope according to climate, it will always stay for the lifespan of the building, which is really a great investment. Everything else can be exchanged or added later. So here are some performance requirements, and I didn't want to go into every one of them. Just wanted to show a little bit what the difference is between how energy consumption is calculated for residential and non-residential buildings. So for residential buildings, including multifamily, you would take the number of bedrooms plus 1. And for multifamily, it would be unit for unit basis. So if you have 3 2-bedrooms, it would actually amount to a 12 unit and not a 9 unit. So for non-residential buildings, we go by the interior square footage of the conditioned floor area, and it's calculated that way. And then they have some ranges which are very nicely all climate specific. Here are some other prescriptive requirements, and the one for pre-certification and on-site verification is something I appreciate most for Passivhaus. Pre-certification gives you a chance to have a peer review with FIUS, and they will point out any troublesome spots and areas in your envelope. Once this passes and you correct any issues you might have had, and the building actually is under construction, you will get on-site verification, and you will get one for foundations when the building air envelope is on with the windows to test for air tightness before the facade is on, so you can still regulate and correct mistakes. And then one is the final test for air tightness. So it's completely performance based. And here are some of FIUS's recommendations, and the building that I'm going to show you right now has actually not gone through the FIUS certification process, but it follows all the recommendations. So this is the building that I'm going to talk about today, and it's located in Huntersville off of 77 in a business park. The use of the building is office and industrial, and it's not very big. It's about 25,000 square feet, and the interesting thing is that the client actually was German, and although this park was grandfathered in and didn't have any regulations to site water or quality control, site water quality or quantity control, they still wanted to do a good job with the site and have the least impact on the site that they can have. So here we can see that we actually left a lot of the woods towards the street, and they will actually provide really nice shading to the west side of the building. And we also left the entire existing tree line on the east side. So when the sun is really low, it will actually protect all of the windows from direct sun for the east side. On the south side, we had a really big overhang for the second and for the first floor, which allows for the summer angles to actually be shielded with the overhang, and for winter angles to shallow come in and perhaps aid in heating the building in the winter time. So that is, I think, for the orientation of this building. Also, we have, this is the industrial part, and this is the office part. So they are separated mechanically into zones. The industrial part has its own mechanical system, and the office portion is divided into zones with PFE boxes. The industrial portion of the building has a different construction type, so the bearing exterior walls actually insulated precast panels, whereas the upper story and the first floor of the office are steel construction with rain screen. Here is the section of the building, so you can see the large overhang here again, which sort of resembles a vernacular architecture of the south, so you have a shaded porch, so to speak, one on the upper level and one on the lower level. Here's where we are at with the building right now. So they are preparing the site, and I think the slab has been poured already. So energy balance is really important in the building for passive house. So we have losses and gains, and we have to level them out. So for losses, we have transmission through the envelope and ventilation losses. And for gains, we have solar gains and internal gains, which is also people inside the building add to internal gains. So here are some of the weak spots of a building that are especially prone to thermal bridging and heat loss, or energy loss, if you will. So here's the connection to the footing from the exterior wall, the connection between the wall and the window. And what we try to achieve is to have a continuous air barrier all around the building like a onesie. And we want a thermal envelope all around the building as well. So here we have underslab insulation, and that it connects with our continuous insulation in the precast panels, connects with continuous rigid insulation in the roof, and then connects with cavity and continuous insulation in our wall system. Again, roof goes around the penetrations of the structure through the envelope, out and around, and connects again to the footing. So I'll try to show that a little bit better in larger details. So this is our south-facing second-story porch. And since we have steel penetrating the exterior envelope, what we did is we actually ran the thermal insulation all around it. In Europe, you can actually make connections that are thermally broken steel to steel, but we don't have them here yet in the United States. So this is what we did. We had to run it all the way through. We were going to do it as well in the bottom part, but for some reasons we have not. So the door actually sits on a piece of rigid insulation that then connects to the insulation below deck. So we have a small thermal bridge right here where the steel beam actually disconnects our batting and rigid insulation. But otherwise, we have a continuous air barrier, which is very important for us in the south, so we don't lose any energy in the summer months when we are air conditioning the building. So then the next detail is the footing and the wall, and you have continuous underslab insulation, perhaps around the footing and up into continuous insulation. So we have a rain screen on the office part, which means that our cladding allows for water and wind to reach the weather barrier. Our continuous consolation is the rain barrier, R45, which has, it's like a 2-inch rain barrier, which works with the cladding system. And R value for that is 8.6. And in the cavities, we have mineral wool, and the R value is 20. So we have an about 28.6 because we didn't do the actual R value for each stud, like Steve was showing earlier. Here we have another interesting detail at the high eave, where you have the rigid insulation wrapping up and connecting with the continuous insulation of the wall. So what is important here is that your air barrier and your continuous thermal insulation actually meets with the window. And then the window serves both purposes until it can connect to the seal again. So here we have an exterior stair, which allows us to access the roof. So we don't have a roof hatch. We have actually a storefront with a door where you can more easily walk out on the roof for maintenance. And what we did is actually set the stair on top of the water barrier and the thermal insulation, not to have any thermal break here. So I thought that was an interesting detail to show, and just to sort of explain the thinking behind these types of buildings. Another one. And then here, as another interesting thing we found, is the energy guard. Because we have a dock door here, it's an industrial building. They leak air terribly. And first, the idea was not to condition the industrial part, but since the work that is being performed is more programming than manufacturing, really, the comfort level of the workers was really important. So for one, what we did is we sliced the building with a storefront. So you can actually, while you're at the factory, you can have views to the outside and you can have a lot of daylight. So daylight studies show that you don't have to even turn on the light on a nice and sunny day. So at the dock door, we would have a lot of air leakage here. So what we did is we used the energy guard, so when it's closed, you don't have any air leakage through the dock door. Here is the precast panel with the 2-inch continuous rigid insulation. So from the FIAS Institute, they have done studies that actually thermal mass in combination with the continuous insulation will jack up the R value of this continuous insulation by 2. So this wall as well has about a 28 R value. So has every wall. Here we have another continuous insulation on the factory with EFIS, which is a self-draining EFIS system. So it will prevent any thermal bridging from the metal studs in the wall. And then again, mineral wool in between the studs. Then we come to the windows. And one type of windows we really like to use in passive house is the tilt and turn. And this is because, well, it looks nice and we are used to using it in Europe, but also it's because it actually air seals the window much better than a double hung, because it actually applies pressure on the gasket and no air can pass through. Another thing that we usually do is provide these windows for ventilation almost solely, and the rest of the window is fixed. This reduces cost and also improves air leakage and also R value for the window. So here on the west side, what we did is we pushed the window in a little bit in a rhythm, so you can get some shading from the wall as well. And here is a typical passive window that is like even 4-layered, which is really a lot. Here for our climate, a 2-layered window is just enough if we have the right solar heat gain coefficient and U value. So here is the chart. That's the FIAS chart, the recommendations, and then you still have to do your energy model to see if everything pans out and to find the sweet spot on how much money you're going to invest in the envelope and windows and how much energy you're going to save. And at one point, adding more R value to the envelope really doesn't give you anything, and just to see where that trade-off is. So here for climate zone 3 in Charlotte, so we see that about the solar heat gain coefficient is very similar to the North Carolina Energy Code, actually. And they divided up the south and the other sides, which our North Carolina Energy Code doesn't divide it. They divide it by the amount of overhang a window has, how much shading it gets from an overhang. But the U value is much, much less. So they want a much higher performing window. So our North Carolina Energy Code requires us to do 0.45 U value. And here we have to go below 0.16 for metal glass, which is really really high performing window, which is great. So here is another project. So in the industrial project, we basically use mineral wool and another type of dense mineral wool board for the continuous insulation, EFS, rigid insulation in the precast panels, so polyiso on the roof. So it's very commonly available materials. And then exterior gypsum sheeting for our exterior air barrier, and basically gypsum was our interior air barrier. So here's another project where we went a little bit more extravagant, if you want. So we actually have a rain screen that is attached to a 2-inch wood fiber board. This wood fiber board is called Gutex, and it's a new product. It's made out of wood chips, really, that are then infused into paraffin. So it serves as an air barrier and as a weather barrier. It overlaps with the tongue and groove, so nothing can get through it, but yet it breathes. So we have 2 inches of this. This is in a different climate, 4A, up in Asheville. So we have a better R value for this wall. It's still metal studs, and we use an interior membrane, which is called Atella. And what this intelligent membrane does is it can open up in the direction of vapor travel. So in winter, when we have a lot of heat in the house and we accumulate a lot of moisture, the moisture wants to escape. So the membrane actually closes and doesn't let the moisture go into the wall, where it could potentially condensate and create mold. So and in the summer, when we have a high humidity on the outside, the moisture will actually pass through and you can dry it out from the inside, which is what you want. Here, this client was actually Swiss, so he wanted his Rollläden incorporated into the wall. So we did that, and we're careful to preserve the thermal R value around it and the air barrier. So we sort of weave it around the structure, so we maintain this continuous air barrier. So we also use the Mento membrane on the top. So in this project, we actually used a lot of foreign imported products that are actually very commonly used in these projects. Here is the Gutex, actually the overlapping sheeting. Here is the Atella membrane. Another thing, wait, just one moment here, is that we actually created a chase wall for electrical conduits. So this Atella membrane will never get punctured. You know, when you hang a picture in the wall and your chipboard is the only interior air barrier, what happens is really you create air leakage through electrical outlets, through pictures hung on the wall, and so on. So here you actually create an electrical chase that doesn't allow for this continuous air barrier to ever be broken.
Hey, Kristina, it's Ryan. We're getting some background noise. Is that from your side?
Yeah, let me.
All right, folks, I think Kristina's probably running to another room, maybe. Sorry about the background noise there. I'll give her just a minute.
Hello, Brian, can you hear me? I'm back.
Yes.
Is it better now?
Yes, thank you, Kristina.
Yes, we have an open office, so it's everything is just acoustically not separated. But here's the Atella membrane. This is what it looks like. It's really easy to apply. And this is the interior air barriers you see, and then the Mento air barriers on the exterior of the building. Taping around this connection between the window and the air barrier is also very important, and taping in between the sheets. There's also some overlap in them, and they're just installed in a very specific way. So what is the difference between the two? The Mento membranes and Atella membranes actually work on a molecular level versus on microperforations. So this, the microperforations membranes, once they tear, they actually don't work that well anymore. These are much stronger, and they don't allow any air to pass through, just vapor, which is exactly what you want. They're also a little bit expensive, but on a project that was, for example, $1.8 million, all of the membranes turned out to be $40,000 just as a wrapper. I think it would be totally worth it to completely seal your building for that amount of percentage of a project cost. And I think, here's another one. Sorry. So why is it important to certify with Passivhaus? It is great to use all the principles and just be mindful of how you build the building and build a more high quality building. But when you actually go for certification, it isn't that much more expensive, but you get a lot of benefit for it. You get team commitment and client commitment. You get with pre-certification, you get the peer review of your drawings. So you actually send in your drawings and you can learn from them. You can make them better and almost perfect. Then when you go into the energy modeling, you can actually fine-tune all of these things and balance cost versus what you're actually getting with making this super insulated structure. You get field inspections, not field, but field inspections with it. So they look actually how you are insulating under the slab. You get another field inspection to see how you air sealed your building, where you can check for leaks and correct them. And then in the end, you do the final blow door test where you actually show that your building meets the Passivhaus airtightness standards. So I really like this system because it's very straightforward. It gives you enormous flexibility with the type of building materials you're going to use, the technology you're going to use. So you can go very basic and buy all of your materials from Lowe's, or you can go high-tech and use high-tech membranes and high-tech heating and cooling equipment. And you can do anything in between. So it's a very simple and applicable, practical way of building, and it's very resilient against power outage, and the thermal envelope lasts much longer, and that's something you'll have for the longevity of the building.
Okay, well, Kristina, thank you so much for that presentation. That was wonderful. Lots and lots and lots of information, so thank you there.
Sorry.
No, it's, you know, we went from like data science into building science and then a little bit of chemistry, actually, with a molecular level, so I was very impressed with that. Thank you. I'm going to go ahead and check the chat box. It looks like we do have at least one question. So, Kristina, here's a question from John. He asked, have you found a North American source for wood fiber insulation?
No, I have found only the Gutex, which is actually manufactured in Schwarzwald in the Black Forest, but it's been distributed by several companies here in the US. All of the Mento membranes also are not produced yet in the US. They are all being imported, unfortunately. But that would be a piece of market for somebody. If John wants to start it here in the US, that would be wonderful.
Okay, so we've got new business opportunities being formed on the NCBPA webinar today. That's good. I know that you mentioned the Atella membrane material. We did have that in the RE redesign build project that I showed that photo of with Dylan and Will. So if folks are interested in some video on that, if you do check out the video on our website, you can see that there. So I'm just checking to see if there's any more questions. I don't see anything here in the chat box. So we'll wait just another minute or two. Kristina, any final comments before we move on to KG's presentation?
No, I think it isn't that hard to use views on your building, no matter if you are registering it or not. And I don't think it actually adds that much cost to your building either. So I think it's all about mindfulness and knowledge. So the more we can connect with each other, with builders, architects, scientists, and learn from each other and find the best way to build these cost effectively and energy efficient, I think we're onto something.
Okay. That sounds great. Well, thank you, Kristina. I think that's a good summary of what this opportunity is. So we'll provide Kristina's contact information to everybody here in just a little bit and in the email tomorrow. So we're going to go ahead and jump on to the next part of our presentation. So this is going to be with KG on sort of the multifamily and panelized side of things. So KG, you should have controls, and take it from there.
All right, thanks a lot, Ryan. Appreciate the presentation so far. My name is Karan Gupta, or KG for short. I'm a project manager at BuildSmart, and we're a manufacturer of high-performance panelized wall systems based in Lawrence, Kansas. Today, I'm going to be discussing panelized passive house systems for new multifamily construction. I have adopted this presentation from my colleague, Paul Grahovac, who has a compelling financial analysis paper to complement it. I'll be happy to send that paper to anyone by request, and you'll see my contact information at the end of this presentation if you would like that paper. I think Ryan will also be distributing that contact information at the end of the presentations. So I'm going to start here with an example of a building, Capitol Flats Phase 3, the Battery. And this is to show that what I'm about to discuss is not just theoretical, but rather the concepts are already being implemented with great success. This building is 4 stories, 25 units, and was completed in 2017. It passed the blower door test on the first try, blower door test, of course, being for the passive house standard at 0.6 ACH 50. And it has also achieved net zero energy consumption. It's actually the first net zero multifamily building in the nation. And it is also the winner of multiple awards. You can see those on the right over there. But for our purposes, the most important note is that the architect, builder, developer, Onion Flats, is paying the tenant utilities. You can read more about this project on the BuildSmart website. Oops, sorry, getting ahead of myself here. So I'm going to discuss another example and put some numbers to it. This project is the Whitehall. It's a 49-unit veterans housing facility in Spring City, Pennsylvania. And this project is the basis for the financial analysis paper I mentioned at the beginning of the presentation. Onion Flats, who is the developer, architect, builder for the previous project, was also a consultant for this project. So using the BuildSmart building envelope with airtight factory installed windows and continuous exterior insulation to eliminate condensation risk in the wall, the builder was able to install 26 linear feet per hour of panel with no prior experience and at a lower cost than stick building. This was also a passive house building, and the final blower door test result was 0.42 ACH 50, and that was with no leak chasing. The significance of that cannot be overstated for anybody that's worked on leak chasing on passive house buildings, especially one of this size. Energy modeling for this project shows energy consumption for HVAC for a 1-bedroom unit at $7 per month. By comparison, running the same model for code-built construction with an estimated 7 air changes per hour at 50 pascals, this number would be $77 per month. So here's where we're going to get into the details of the financial analysis. It's common in multifamily housing to submeter individual units and bill tenants separately according to actual usage. Another strategy is for the developer owner to pay tenant utility bills and charge tenants the market rate utility cost. In the case of passive house construction, the difference between these values can be significant, as demonstrated with the Whitehall example. The developer owner benefits from higher monthly revenues, while the tenants benefit from fixed monthly payments, thermal comfort, superior indoor air quality, noise attenuation, and so-called green cred. This next series of slides is taken directly from the developer of the project, Mission First Housing Group, where they show how Passive House made them money. So here you can see that as a result of the lower utility costs on the Passive House building, the collected rent is higher than would have otherwise been the case. You can see the note, I'm sorry, I had the wrong slide there. You can see the note pointing out that the operating costs for common areas are understated for the base case, which actually would further widen the gap in net income between code built and Passive House. So what's shown in black here is they put in the same operating cost for what it actually was, but if you were to include the, if you were to properly value the operating cost for the common areas, it would actually be higher, and therefore the net income would have been less for a code built. So the increased net income for the passive house building increases the developer's borrowing capacity by $300,000, and the increased mortgage amount translates directly to a higher net fee for the developer. Because the developer for this project is a nonprofit, they can plow the increased fees directly back into building more affordable housing. So the Whitehall project in the case study we just looked at was affordable housing. But how do the numbers compare when you're looking at market rate housing? Well, Paul undertook the task of a financial analysis for the same building if it were built to code in Kansas City and if it were built to passive house without any subsidies. As you'll see in a moment, the results are promising, but when comparing new passive house construction to legacy housing stock rather than to new construction to 2012 code, the numbers are even better. So in the chart shown here, owner A owns a building just like the Whitehall in Kansas City, built to the 2012 code. Owner B owns a similar building, but this one would be built to passive house in Kansas City. You can see there's a 3.76 cost premium for the passive house building. Owner A pays the utility bills for the common areas, and the tenants pay utilities for the living units, whereas owner B charges tenant utility allowance and pays all the utilities. And you can see a net revenue increase of $41,223 for owner B. I'm just going to read this slide to you. It says, according to the National Conference of State Housing Agencies, breakthroughs in modular and prefabrication techniques can now cut construction times in half and shave up to 20% from development costs, according to research from the Turner Center for Housing Innovation. Just keep that in mind as we get towards the end of this next slide here. I know there's a lot of numbers there. I'll try to walk you through them slowly. Don't worry about the numbers down to the single dollar digit numbers. But let me just walk you through this table. In the base case, the net annual cash flow is the difference between the additional revenue from the energy savings and the additional cost of the mortgage payment attributable to passive house construction. With this net annual cash flow, it would take 10 years and 9 months to achieve payback on the cost premium. But as we work across this table to the right and factor in additional savings from passive house and panelized construction, you'll see the payback start to drop. The first thing we can look at is first cost savings on the HVAC capital expense due to reduced loads for passive house building. After that, you can add in fixed windows with lower maintenance costs and failure risk. So that's basically changing some of the operable windows to fixed. These next three columns here relate to the increased speed of construction of panelized systems, which reduce the construction loan interest and contractor overhead, while also allowing rents to start sooner. This is assuming a 10-month construction schedule shortened to 8 months, but in reality at the Whitehall, the schedule was shortened from 10 to 7 months. So these are actually conservative values. When the present value of avoided 20-year window replacement is added in, the payback is dropped from 10.75 years to 4.92 years. But if you recall from the previous slide, the reduced construction costs from prefabrication described, then the increased construction costs of passive house are actually offset before the construction fence even comes down. So in effect, that 3.76% cost premium for passive house, when done with panelization, actually becomes a 4.8% cost decrease. This decrease is further reduced when you account for HVAC savings and avoided window replacement as shown on this slide. The uptake in passive house construction for affordable housing in Pennsylvania supports the conclusions of our case study and financial analyses. And I tried to keep this short, so that gets us to the conclusion. Here's my contact information in case any of you would like to reach out to me. I'll take questions, but if folks are still sending those in, I've got a couple more slides I could share that might be eye-opening for some further opportunities. Ryan, do I have time to go through that? There's literally just 2 more slides.
Yep, go ahead. We've got a couple more minutes and then we'll have Leah wrap up.
Okay, great. So let me skip ahead here a little bit. Okay, so this one, especially for folks in the Triangle area, I think this might be of relevance. One thing that's not really considered as a primary benefit of Passive House, if folks look at the quality of life benefits in terms of thermal comfort and indoor air quality, we look at the energy savings. And of course, we all know intuitively that super insulation is going to mean less outdoor noise. But what does that mean for developers? It actually means that land that's previously not really been suitable for development now becomes suitable for development. And what I'm speaking to specifically here is train tracks. So you can see a few links over here. And effectively what that means is that train horn outside, if you have with passive house construction, the sound of a passing train or the horn at maximum volume is about equivalent to the hum of a dishwasher. So this is my final slide, and it's just kind of showing that this is a plot of land over in Kansas City that's kind of been sitting fallow for a long time, just waiting for development. And again, with Passive House, these areas now become suitable for multifamily development. So with that, I'll just go back to my contact information and I'll take any questions at this time.
Okay, great. Well, thank you, KG. Another wonderful presentation. Appreciate all that information. I'm going to take a look at the chat box and see if there are any questions here. I see Christina's been responding in the chat box. Thank you, Christina, for that. And I don't see anything else. So, KG, thank you. We'll keep you on the call until we wrap up, and then we'll see if we can open it back up for some more questions here at the end.
All right, thank you.
Okay. All right, so we are going to jump ahead to our last presenter, and the reason she is last is that she can take our homes and buildings down to net zero energy very easily, cost effectively, and whatnot. So Leah, I jest a little bit because I know it's not that simple, but do you want to tell us how to do it for the real world?
Sure. So, hey guys, I am Leah Dickens. I'm the Green Building Manager with Deltec Homes. We are actually sort of like BuildSmart in that we are also a panelized company. Our manufacturing plant is in Asheville, North Carolina, but we focus on residential, single-family residential construction. And so we build our home kits in Asheville and ship them all over the world for people to erect with a builder on site, and we have our own builder in Asheville as well. And so I work as like a building science consultant for our builder, other builders, and for our clients on green building. And we recently built one of our homes to the DOE Zero Energy Ready Home program. So this is not Passive House. I'm actually here to talk about not Passive House. But I wanted to talk about how some of the aspects of this program that maybe look at energy use a little bit differently could be beneficial to a Passive House project. All right, let's go to the next slide. So a quick overview of this program. It's another third-party certification program. This one is put on by the Department of Energy. And surprise, actually, if you're doing the FIAS standard, it's a co-requisite, so you should know about it, actually, because you've got to do it as well if you do the Passive House US version of the program. It's the next step above Energy Star, which is another well-known green building program as far as performance. So its target performance level is in this mid to low 50s HERS score, which is certainly respectable performance. And the idea is that it's taking common sense strategies. It's actually based on the Department of Energy's Building America research goals, where they've done various research and funding, and they're trying to take a lot of those strategies they've come up with and really get them into the marketplace with this program. So certainly it has reduced emphasis on heating and cooling load reduction compared to Passive House. It does not take the envelope as far, but it has some unique other requirements for tackling home energy use, as well as the zero energy ready component, and I'm going to talk about those. So this is like a super nutshell of the requirements. If you've ever done Energy Star and you've seen like the pages of footnotes, this program has got those too. It's actually fewer pages, but basically the core requirements are these. You've actually got to do Energy Star for homes anyway. That gets some of the basic building science concepts in there, like HVAC that's designed with manual JAS and D, et cetera. The grade 1 insulation, fresh air ventilation has got to be in there. Its envelope requirements are the 2015 IECC at a minimum, with Energy Star qualified windows, and the air tightness varies based on climate zone, but in the North Carolina zones, it's going to be 2 ACH50 in zone 5, and then 2.5 ACH50 in zones 3 and 4. It requires ductwork and air handler to be totally inside conditioned space. There's an asterisk here because how that's defined, it's worked out in the footnotes. You can go read those. And it requires efficient hot water distribution. That's a new one, so I'm going to come back to that. Requires that any appliance that can be Energy Star certified, fridge, dishwasher, bath fan, ceiling fan, clothes washer, those have all got to be Energy Star certified, which funnily enough is not true with the regular Energy Star for Homes program. You've got to do Indoor Air Plus as well. That's tackling the air quality aspect of a high performance home. So there's a number of small things, but important things about low VOC products, moisture resistant materials, doing radon mitigation, having upgraded filtration, et cetera. And in addition, you've got to either have solar PV or follow a solar ready checklist if the home has enough solar energy to justify, or solar access, like it's not shaded, it's got enough solar energy available. All right. So this efficient hot water distribution is a new one, and I wanted to talk about that because it's a little bit different. The aim is to reduce water and energy that's wasted while the client is waiting for hot water to arrive at their faucet. Basically, the rater has to measure that no more than 0.6 gallons are coming out of the faucet before a certain temperature rise is reached. And I remember being a little bit perplexed that this was part of the program because while it clearly saves water, it seems like the energy savings wouldn't be necessarily as significant as some other factors that they don't require, like the more aggressive envelope design in Passive House. And so when I asked the DOE about it, their comment was to look at this like a customer satisfaction issue. If high performance housing is going to take off, clients should be happy with all of the features of a high performance home. And long wait times for hot water was a common complaint that they were seeing. That's actually something I've definitely had clients complain to me about. So it's really targeting at making the client happy with the home. So the ways that you can meet this requirement: you can limit the piping distance between the water heater and all the fixtures that use hot water using like compact plumbing or a central manifold kind of system. In the newest version of this program, you can also meet this requirement by having water sense fixtures at every faucet, plus a very efficient water heater, and there's still some caveats to making that work. Or you can use a hot water recirculation loop with demand activated controls to ensure the energy savings, and that's actually what we did on our project. So we had a heat pump water heater in this project, which I've pictured below here, which is great for energy savings, but it makes noise and it puts out cold air. So for client satisfaction reasons, we weren't able to use the compact plumbing and locate it. It would have been located too close to their bedrooms and we thought they would have been bothered by the noise. So we did the recirculation loop. What that is it's basically, it's a typical trunk and branch plumbing system, but it's adding a return loop to bring water back to the water heater. And so you have small branches off of that loop to each fixture. And that pump is what's kind of controlling it. So it's basically bringing the cooled water back to the water heater to get reused instead of having it being sent down the drain. The pump basically runs until the water's hot enough and then it shuts off. So when you're doing this, the way to save energy is to use demand activated controls for the pump. For the Zero Energy Ready Home program, that's got to either be a button that the homeowner activates when they want hot water or an occupancy sensor. And there are some pumps that have like adaptive control systems that learn the homeowner's behaviors, and those are okay too. What it can't be is a timer, and that's kind of commonly how these systems are set up. And I've actually even heard horror stories about how they don't think about controls and they're not controlled at all and they just run all the time. And those systems, they find, end up wasting energy rather than saving it because they come on when the homeowner doesn't actually need them. So the DOE says it's got to be demand activated for this program. And that's what we did. We had a button in each bathroom, pictured here, with the LED light that says when the pump is on. The light goes off when the pump is finished running. The homeowner then knows that the water is hot, I can turn the faucet on. So to meet the zero energy ready part of this, one way to do it is to just have solar as part of the project, which is what we did in our example. We had a grid-tied solar array. We used the HERS score to help figure out the size for the home. Basically, we were looking to be in the 0 to 10 HERS range, and we ended up at 0. In North Carolina, solar is pretty easy to do. If you're on Duke Energy, then they do have a one-to-one net metering program that lets clients they basically buy back the excess production at the same rate as retail, and then clients can credit that against their future energy use. If you're on an electric cooperative, the story is more mixed. You just kind of have to look into it and see what their programs are. And my real advice is just to have an experienced residential solar contractor work with you on it. There's a lot of in North Carolina, and it's actually pretty simple. But if you're not going to do solar as part of the project, but you have enough south-facing roof space for solar that's not shaded, then you do have to do the solar ready checklist for this program. And what that requires is some basic stuff to give to the homeowner to make solar easy. And I think that makes lots of sense for a passive house. So you've got to provide drawings to the homeowner that show them where the solar array is going to go, basically how big it's going to be. And they advise that you can go ahead and put blocking in, like if you need to, for the roof or for the inverter to fit the solar panels. To go ahead and provide structural information that verifies that the roof can support solar. Commonly, when you go to do solar on a retrofit and you get a building permit for it, that's one thing they ask for is, yes, structurally will it do it? So going on and giving the client that information is helpful. You've got to go ahead and install and label the conduit between the solar array and the inverter, where those things are going to be, and then between the inverter and the electrical panel. And you've got to go ahead and provide the breaker or provide the labeled slot for the breaker, a 70 amp dual pole breaker for solar. All right. So just kind of continuing with this theme of ways to reduce energy that are not necessarily the same concept as passive house. Zero energy ready home doesn't require whole house electrification, but there are just a lot of electric appliances that can use a lot less energy, so they're worth looking at. In this project, we actually used a heat pump dryer. That wasn't something I thought of. My client actually researched that and was like, hey, this seems cool. So these are neat because they are more efficient than a regular dryer because they're kind of recapturing some of that heat. But that also means they don't have to have a vent. So you're eliminating that one hole in your building envelope when you do that. Induction range is another common, more energy efficient way of providing cooking. It's electric, but it uses magnetism. So magnetism to heat the pot. And it also provides an experience that's a little bit more like gas or propane, but without the indoor air quality problem that is a gas or propane open flame. So I've actually been able to convert a number of diehard gas fans to induction. I mentioned that project used a heat pump water heater. I think that's another great idea, depending on your floor plan, if you can get it out of being in a place where it's going to bother the homeowners. I've actually heard a common statistic that they use about one third the energy of a typical electric water heater. That project did use mini split heat pumps as well. I know Steve had talked about those earlier. I think that that's kind of a good idea in North Carolina just because you're probably going to be using a heat pump and AC anyway. That's a pretty efficient way to go. So that's an electric way of doing all that very efficiently, especially if you're doing a passive house where your heating and cooling loads are probably going to be so low that most other types of heat pump systems are probably going to be oversized. But there is definitely some complication with how you design them and distribute them to not oversize them, but also sort of distribute the heating and cooled air to different rooms. So I think the general strategy that you can accomplish when you combine thinking about reducing your energy load in other ways with passive house is that the energy loads of that home are so low. You've done it through passive means, and then you pick smart technology choices to reduce the energy load even further. It becomes really easy to offset that load with solar PV where possible, and that's really the goal, to reduce the energy demand of buildings in North Carolina. So I threw some resources on here for more information about the program just to finish up my presentation. So how's that, Ryan? 3 minutes left.
That was amazing, Leah. Thank you so much. I know you did that quickly here at the end, so thank you. We'll give your voice a chance to catch up here for just a second, and check in the chat box. I know there's been some conversation going back and forth between Levi and it looks like KG. So looks like you guys have been responding, and there's a good answer in there. And Levi said yes, thanks. So looks like that's good. So yeah, let's see if there's any other questions for Leah. You know, we brought her in to just kind of provide this other flavor of Passive House, which is, you know, a little bit more focused on the renewables and some of the mechanicals and whatnot to push it down to that extra level. So if there are any questions, then please do put those in the chat box. And Leah, we'll just wait a minute or so here to see if there's any questions for you, and then we'll open up the line and do questions for anybody else. So Leah, while we're waiting, any other just plugs for your work or for any other resources that you think people should be looking into?
I guess I'll just comment that from the builder perspective, I like the Zero Energy Ready Home program because it's a combination of not being too complicated and onerous, but being like a legitimate step up. And I think I liked it about Passive House Plus too, like Kristina had mentioned. But sometimes the window and some of the other requirements, this is just a different, probably a little bit of a lower cost way to go. It doesn't definitely do as much of a envelope performance, but it can get really pretty respectable too.
Gotcha. Okay, thanks for that. Yeah, we're definitely interested in educating, you know, regular old residential builders and, you know, some of the folks on the commercial side as well about, you know, the different opportunities they have for these programs. And I think Kristina said it a couple times. We didn't focus on it a whole lot, but, you know, the certification versus sort of the principles and techniques and things like that. You know, I think from our association's perspective, we just want to see great buildings out there, and there's different ways to do that. So. Okay, well, thank you, Leah. So I don't see any other questions, so we'll be happy to open up the line and just see if anybody has any questions. We can do that on the chat box here and see if anybody has anything. And then if any of our presenters, Steve, I know since you were up first, if any of you guys have any additional comments on the other presentations or want to ask somebody else a question, we've got you all's audio up and running, so you should be able to unmute yourself and go ahead and get some discussion going or have a chat with anybody if you'd like to. And I'm just going to see if there's any other questions coming in, and we'll wait a few minutes here. Just as a reminder, we will send out a recording of this webinar probably tomorrow morning, so be on the lookout for that. We'll make sure to include a PDF as well, and then we will also provide contact information. So I do have our presenters here up on the screen. While we're waiting for questions, I'll go ahead and we'll do a couple of wrap-up slides and see if anything comes in here. So do want to thank Steve, Kristina, KG, and Leah. Didn't get that typo, Leah, sorry, in the last one, for being presenters for today. Really appreciate y'all spending some time with us, and that was tremendous information, so thank you so much. Again, we'll put contact information in the follow-up email, so you guys will get that here very soon. Also, just a final ad for NCBPA, of course, we're membership-based, as I mentioned at the beginning. We would love to have any companies on the webinar or listening in later on the video that are not members of ours join. You can find information on our website, buildingnc.org, and dues are as little as $25 per month. So we definitely appreciate all the support that we get, and look forward to continuing to talk about this topic and many others. This is my contact information in case you need it. So you can reach me on cell, email, and sometimes at the legislature where I was earlier today, and back tomorrow to push those types of policies and market development. So I'm going to check the chat box. I think there was at least a comment that came in, I think, from our friend Mike. There it is. And Mike Cap with NC State Architect said NCSU will be advertising for designers for a multifamily project this weekend. So that looks like a fun announcement. Thank you, Mike. Kristina, hopefully you saw that one and can be in touch with Mike and the powers that be over there.
I did. That sounds awesome.
Okay, more business development opportunities here on the NCBPA webinar. So great. Okay. Well, presenters, if any of you guys have any final questions or comments or anything, feel free. Otherwise, we'll just wait a couple of minutes to see if there's anything else that folks want to chime in on the chat box. And otherwise, we'll wrap up the webinar. So presenters, do you guys have anything else to add?
No, thank you very much.
I had a question for Steve.
Go ahead, Leah.
Steve, I had a question. You had that slide about that T-stud, which is pretty cool. I had recently heard about that too. But there was something where you had some numbers about costs or maybe cost savings to do with it. And I wanted to see that and if you would explain that a bit more, because I thought that was pretty interesting.
Yeah, those numbers were from the manufacturer as what they estimated, for instance, on a 2,500 square foot home, what the extra expense would be. And for, I think it was a 2,800 square foot home.
Okay, so that's the extra expense is what they're saying that is.
Mm-hmm. Seems to be pretty reasonable, really. I mean,
Yeah.
when you think about adding, the alternative would be exterior continuous insulation or a myriad of other things. And again, it's attacking the problem internally instead of having to go to the outside to break that thermal bridge. And the other thing I thought about too is they are using closed cell spray foam, which obviously is quite expensive. You may be able to use a spray fiberglass in that same cavity and basically, approach the same characteristics, if you will. And that may lower that cost too. I don't know that for a fact, but that's something I would think to ask them for as a question.
Yeah, I would wonder if structurally that there's some rigidity added by the closed cell foam or something.
Absolutely. They went through some of that as well. They gave some impressive hurricane testing numbers. I couldn't believe what they were talking about, shooting things out of the cannons and what the wall did without any extra support and all that. So it was quite amazing.
All right, so it looks like I'll be reaching out to the folks at T-Stud to see if they want to do some advertising here in North Carolina. So thanks for that lead, Steve. Okay, I don't see any other questions in the chat box, so I think we'll consider today's webinar done. So thank you, everybody. Thank you, presenters, for sticking around and providing all this great information. Hopefully, folks got what they needed out of this one, and we will, of course, be doing some more webinars here in the near future on building envelope, kind of the sealing and membrane side of things. We've got a little bit of information developing on that. Cybersecurity is coming up. That's kind of a new one for us. And then a couple of other topics as well. So we'll be sending those out to folks via email soon. So thank you again, presenters. Thanks to all the attendees. Thanks for folks listening in later on. If you do have any questions or comments, concerns, need help, and anything, just let us know over here at NCBPA, and we will be happy to help you. So thanks, everybody. That concludes today's webinar, and look for an email from us in the near future with the recording and some additional information. So thank you, everybody, very much, and have a great day.
Thank you all.